morning, friends. A hearty welcome to my YouTube channel. Friends, in today's session, we are going to work out a problem on a semicircular lamina, a half lamina like this. They have specified what the diameter is for this lamina. It is resting on the line of intersection of HP and VP. So that they have given here. That is to say, it has to rest on the longer diameter, which is 50 mm, on HP and VP. So friends, what do we do in this problem? We place the lamina on HP such that the diameter is perpendicular to VP and obtain the front view a line on XY and top view a semicircle. So we are going to commence with the top view of the lamina, which is lying on HP with the diameter perpendicular. So this is a semicircle. So friends, I will call these points as A. This point is A. This is B. This has got a diameter equal to 50 mm. I will mark it here as 50 from here to here. Then I divide this into 4 equal parts since it has no edges. So a horizontal line will divide the semicircle into 2 parts. Again a line here at an angle of 45 degree and the line here at 45. So totally the semicircle is divided into 4 equal parts. So I will call this as 1, this as 2 and this point as 3. Now the lamina is resting on HP with the diameter AB normal to VP or perpendicular to VP. And let us obtain the front view of this. The front view very obviously is going to be a line on XY. So this point is going to be A dash, B dash. This point is 2 dash. This is 1 and 3. They fall on the same line. This is 1 dash, comma, 3 dash. So this line on XY represents the front view of the lamina when the lamina is resting on its surface on HP. But in the question he says, so while resting on this edge, the highest point is 20 mm from HP. So friends, I am going to write a line here parallel to XY at a distance of 20 millimeter from it. So on which the highest point 2 should lie finally. So friends, take any point at random on XY. Take the length M, that is the distance between this edge to this edge, which is going to be very obviously half of the, that is radius 25 mm. So take this and strike an arc. So I will take this A dash B dash as center and radius equal to M, which is equal to 50. I strike an arc and join that point, the so called 2 dash to A dash B dash. So you can locate the point 1 3 by taking this distance here. So it will come somewhere here. This is 1 comma 3, 1 dash comma 3 dash. Friends, the highest point is now at a distance of 20 millimeter. So for this front view, which has got a length equal to M, which is equal to 25, we have to obtain the top view. So let us start from this point A and B. Draw a vertical line from a horizontal line from here. The point where those two intersect is point A. Similarly, vertical line from B, horizontal line from B. The point of intersection of these two will give you B. Very obviously, friends, this side AB, there's a diameter, will be straight, and this will also have the same length 50 mm. Obtain point 1. Try a vertical line from 1, a horizontal line from here. The point where those two intersect is point 1. Likewise 3. Vertical line from 3, horizontal line from 3. The point of intersection will give you point 3. Finally, the highest point is 2. Vertical line from 2, horizontal line from here. The point of intersection will give you the point 2. Friends, this AB is going to be a straight line. but this part A1, 2, 3B is going to be a curve. So join these points 1, 2, 3 to A and B by a continuous smooth curve. So this figure will represent the top view of the lamina when the lamina is making an angle of theta. So this theta can be measured using a protractor. That is asked in the question. What's the angle the surface of the lamina is making? So very obviously when this is making an angle theta, the angle made by the surface with VP, that is phi, is going to be 90 minus theta, whatever will be the angle, because the vertical plane and the horizontal plane are at right angles to each other. Friends, we have got the front view and top view, and if you observe the top view, the edge AB, which is measuring 50 millimeter, is normal to VP, but it says it has to lie on the line of intersection of HP and VP. Means AB should lie on the XY line extended on the XY. So friends, I am going to redraw this figure with AB on the XY line. So for that purpose, we are going to enclose this semicircle, semi-elliptical part in a box which we usually represent as PQRS or PQ. Friend, now I have enclosed the semicircle in a box APQB, this rectangle. So now I have to redraw this figure such that AB falls on this XY. Friends, I will draw this rectangle with AB and XY. So I will mark that AB, which is very obviously going to be 50 millimeter. So this figure I am going to draw here is same, should be same as this. So this is point A, this is point A, this is point B. Obviously this is going to be 50 millimeter. So this is 50. AB is 50. Then we have got PQ. This is PQ in the box. So this box has to be drawn using thin lines. Now friends, let us locate point 1, 2, 3. 2 is exactly between P and Q. So I can mark it as the point 2. How to locate the point 1? Point 1 is closer to this. So take this gap on PA nearer to P. This gap I have taken. Again this gap PA, you should take this distance and get the point near to AP is point 1. Point 2 you have got. You extend this line further. At the same distance from here, you are going to get the point number 3. Just mark it here. This point is 3. So friends, join A1 to 3B by a continuous curve, smooth curve like this, and the longer the diameter by a horizontal line. Friends, this semicircle with AB or the semi-ellipse with AB on XY will represent the final top view of the semicircular lamina. Now friends, finally obtain the front view corresponding to this. The procedure is very simple. So draw a horizontal from A dash, the point A vertical from here, they meet here. We will call this as point A dash is going to become point B dash. Then the highest point is 2. That comes exactly in between this AB. So probably somewhere here. This is going to be point 2 dash. Then obtain 1 and 3 on this line. So how to get this point 1 and 3? So draw a vertical line from A or 1, horizontal from 1 dash. The point where those two intersect is point 1 or 1 dash. Similarly, at equal distance on the other side, you will get point 3 dash. So friends, join A dash, 1 dash, 2 dash, 3 dash to B dash by a smooth continuous curve like what I have done in the top view. Friends, this semi-ellipse A dash, 1 dash, 2 dash, 3 dash, P dash represent the final front view of the lamina, and this A123B will represent the final top view of the lamina, and this will give you the complete solution of the lamina when the lamina is resting on the line of intersection of HP and VP on its diameter. Friends, I hope the presentation was interesting, and if you feel that it is going to be of some help to the students and the people who see this video, please share this information with all your friends and have a nice day. Thank you very much.